Okay, so here's another problem. We want to determine all the forces again in this truss. And before we get started, let's see if there's any zero force members that we can identify. Yeah, so remember, case 1 was 2 members connected at a joint, no load. Looks like A qualifies for that. So right off the bat, I can tell you that this element and this element are 0. I don't see another case 1. Looks like C would be a case 1, but there's a load applied, so that rules it out. Are there any case 2 situations where you have 3 elements, 2 are collinear? Looks like E's got it, but there's a load at E, right? There's a reaction, so that reaction probably is non-zero. B is 3 elements, because when this one comes out, you're just left with 3, 1, 2, 3, but 2 are not collinear. And D, for the same reason now. So we got 2 very quickly. So this problem looks like it's not going to be nearly as challenging as the previous problem. So let's start by finding our reactions first. So I'm going to go to E, and I'm going to assume that I have a vertical force, a reaction EY and EX. And over here at D, it's a roller, so no horizontal reaction, but there is a vertical reaction. I'll call that dy. Again, I'm just making assumptions. I always like to assume up for y and to the right for x, just habit. So using the whole structure as my free body diagram, we could sum forces in the x direction and immediately get EX. We could sum forces in the y direction, but we can't get both of those. There's 2 unknowns, 1 equation. But we can sum moments. So I think a good place to start always is a pin. So I'm going to sum moments at E. So again, using right-hand rule for my sign convention, I'm going to sum moments at E and make sure it's equal to 0. Well, that's weird. Me equals 0. You might think that too, but you're all worth something. You're all invaluable. You're not equal to 0. Sorry about that. Okay, so about E, the applied force of 100 kips. By the way, kip's 1,000 pounds. That's really 100,000 pounds. Pretty big force. So the moment about E, is that a positive or negative moment?
Negative.
Negative. So I'm going to start negative. So we have a force of 100 kips, and the distance from E to C looks like 30. Right? 15 and 15, 30 feet. Then I've got dy. What kind of moment about E does dy create? Positive. So it's force dy times distance. Distance is 20. So it looks like dy is going to be 150 kips.
Yep.
And it is up. And that makes sense too. If you look at fixed about E, if I pull this truss with this applied load, it's going to want to rotate clockwise. I need to push something back counterclockwise to balance it. So that makes sense. Now we can go ahead and sum forces in the y direction. Since we have dy, we'll be okay. So EY and dy are both up. dy up. EY up. That's it. So it looks like EY is just minus dy. So EY will be minus 150.
So there, when you did the distance from E to C, what makes it to 30 instead of 20? Like, why don't you slide?
Well, remember, it's always the distance to the line of action of the force, right? So here's the line of action of the force. What's the distance from E to that line? It's the vertical distance.
Okay.
And the line of action of dy is here.
Okay.
And that distance is 20.
Okay. So if CF would be pointing up, then would be 20.
Say that again?
If force F would be pointing up.
If
it was a cable pulling it up on the vertical direction.
I'm not what you mean. What do you mean by force F?
That force right there.
This force, it's horizontal.
Yeah. So, but if it was like pointing up.
Oh, that would be different. So the line of action would be the same thing here at DC.
Okay.
So that distance would only be 20.
Okay. Thank you.
Sure. Then the last little bit we can do here is to sum forces in the x direction. We have EX to the right, that's positive. And we have applied load to the right, also positive. So it looks like EX is opposite that, or I wrote a negative, but it's positive. The negative's over here. And that makes sense too, since the only applied force is to the right, the only horizontal reaction got to be to the left to balance it. So now we're left with 1, 2, 3, 4, 5 unknowns. Let's ask this question. Can I go initially to B? No. There's 1, 2, 3 unknowns. I couldn't get anything there. Can I go to C? Sure. 2 unknowns. Could I go to D? No. 1, 2, 3. What about E? Well, it looks like 3, but I already know one of them. So E would be okay, and C would be okay as places to start. And I'm just going to, again, do them alphabetically, so I'm going to start at C. Also, another great thing about C is you'll notice that if I isolate C, I'll be able to find these 2 bar forces, and I won't incorporate any previous results. If I go to E, my answers for these 2 will be in terms of EX and EY, which I'm pretty confident I got right, but if I did get them wrong, that answer definitely propagates into my solution. So if you can find some kind of independent place that doesn't require previous information, that's probably a good place to go. So here we are. Here's joint C. We've got our applied load horizontal of 100 kips. And then I'll assume tension in CD and tension in BC. I probably need to look at this rise over run of this guy. So it looks like it's 40 to 30. Hey, what do you know? 3, 4, 5. So that's a 3 to 4. And of course, I know the hypotenuse of that is 5. So looking at this situation, can I get one of these unknowns with one equation? Yeah, if I sum forces in the x, then only one unknown, BC, has an x component. CD does not. So I'm going to start by summing forces in the x direction, and I'm going to assume to the right is positive. Let's see what we get. So I have 100 to the right, positive. I have BC to the left, that's negative. And the horizontal component is 4. So that's going to be 4/5 of BC. So it looks like BC is going to be positive, and that's going to be 125.
Yes, sir.
And that's kips. So BC is positive, and that's in tension. Seems reasonable. Now that I have BC, I can sum forces in the y direction. And with my value for BC, I can find CD. So summing forces in the y direction, I've got CD, all y, acting down. So that's minus CD. And then I've got the the vertical component of BC down. And that will be 3/5 of BC. And I can put BC right in there. And I can solve for CD.
75.
Sorry, what was it?
75 kids.
75? And I got a negative value. This is in compression. Okay, so let's look at our strategy. So I've got, let me go ahead and I'll just put a little mark through them. We've got these guys. So I only have these three left. Where do you want to go? Well, now we could go to a lot of places. I mean, B opens up, D opens up. I still think E looks better. Why? Well, look at the bar force. What is it? It's all horizontal. What about this bar force? All vertical. That's going to be a pretty easy set of equations to do. So let's do that. Let's go to joint E. The one disadvantage is that if we make poor calculations for EX and EY, they're now going to propagate through. So EY I found to be negative 150, so it's actually down. EX I found to be negative 100, so it's to the right. And then I'll assume tension in force DE and tension in force BE. We already found the force AE at 0, so I don't even have to put it in there. So now it really doesn't matter which one you use. I'll sum forces vertical first. So I just have the force BE acting up, and then I've got minus 150 kips acting down, so the force in BE is 150. So BE, so that's tension. And then I'll finish up my equilibrium equations by summing the forces in the x direction, making sure they're in equilibrium. So I've got F DE to the right, that's positive. And I've got the 100 kip to the left, that's negative. So it looks like the force DE is also positive 100 kips. Did I do that right? I think so. So that makes this tension too. So I only have one force left now. What is it? BD. Now really, I could go to B or I could go to D. I think there's an advantage to one over the other. If you go to D, you're going to have 1, 2, 3 forces with Y components, and you're going to have 1, 2 forces with X components. If you go down here, my unknown has X or Y, and the other ones are just X or Y. So I think D is going to be easier to deal with. So let's do that. Unfortunately, I'm going to run out of space, so I'm going to have to drop a new sheet over the top here. Just a second to drop on a piece of tape. And let's go and do joint D. So there's joint D. I have dy, and dy I solved for was 150 kips up. I have a force in DE, horizontal. I have a vertical force in CD, and then the one I'm really looking at, my last unknown, BD. What's the slope of this guy? Looks like the run is 20 for a rise of 15, so it's another 4-3 triangle, which are convenient. Now remember that we already know DE and CD. I'm kind of inclined to sum forces in the X direction because I don't have to worry about the reaction force or this guy. It's a little bit less work. So that's what I'm going to do. I only have one unknown. I just need to write one equation. So I'm going to sum forces in the X direction. And when I do that, I've got the force DE to the left. That's negative. I've got my BD force. It's also negative. And I just want the horizontal component, so that would be 4/5. Now, we solved for DE previously. It was 100. So it looks like the force in BD is going to be negative 125, I think. Right? You plug in 100 here, multiply by 5, divided by 4. Is that 125? And that's that. So this would be compression. So just to recap, let's see, we got compression here, tension, tension, tension. These are zero force members. So any questions about that one? That was only 18 minutes. This is more reasonable, I think, for an exam problem. All right.